We're asked to find the equation of the normal to this curve where x is equal to 2. Right, I'm going to talk about it. I think I like to draw graphs to show what's going on. And although this is a complicated function, it is possible to draw it okay. You don't have to go down this avenue and you might be a bit unsure, but let me talk about it anyway. Right, 1 over x squared actually looks a bit like this. It's like 1 over x, but this part becomes positive rather than down here. If I was to times it by 6, then I would just stretch it in the y direction. It would still look a bit like this. And then when I'm minus 5, I'm actually going to do a translation by minus 5 in the y direction. And so my actual graph will look like that. And there'll be asymptotes here. Now I'm being asked to find the normal when x is equal to 2. That's actually going to become negative. So it's going to be down here. And the normal, well, let me draw a tangent first of all. The tangent would look a little bit like this. And the normal is the one that sits at right angles to that. So this is what we want to find the equation of. How do we do that? Well, first of all, we're going to need to know the gradient of the function. Or should I say the instantaneous gradient? And I can write it as 6x to the minus 2 minus 5. Then to get the gradient function, I can differentiate. So it's going to become minus 12x to the minus 3. Or minus 12 over x to the 3. And I'm looking at a very particular point when x is 2. So when x is equal to 2, dy by dx is equal to minus 12 over 2 cubed, which is 8. And this has got a common factor of 4, so it's going to become minus 3 over 2. Yeah, I've got a negative, and this is the gradient of the tangent. But I've asked for the gradient of the normal, and remember that is at right angles. So the gradient of the normal, it's the negative reciprocal. It's actually 2/3. So you just switch it around and get rid of the negative because the 2 have to times to give minus 1. And we're nearly done. We've got the x value, we've got the gradient. We just have to work out the y value. And when x equals 2, y is going to equal 6x squared minus 5, remember? So it's going to be 6 over 4 minus 5. I might as well write that as 3 over 2 minus 10 over 2. So it's going to become minus 7 over 2. So actually my sketch is pretty good. I've managed to put it where y is negative. Now let's look at the equation. It's best to use y minus y1 is equal to m x minus x1. This is point gradient form. Just allows us to substitute these points in. So y minus 7 over 2 is equal to 2 over 3 times x minus 2. Just going to change this around so it's a plus. Now we could expand the bracket, but actually we need to get rid of the fraction because the question says to leave it in the form ax plus by plus c equals 0, where a, b, and c are integers. So I actually need to times through by the lowest common multiple of 2 and 3, which is 6. So I'm going to times through by 6, 6y. Now when I times this by 6, the 2 is going to cancel partially with the 6, so it's just 3. So it's going to be 7 times 3, 21. And similar over here, 2/3 times 6. The 3 is going to cancel partially with the 6, and it's going to be 2 times 2, 4. Okay, I didn't show my working for that, but I explained it. 6y plus 21 is equal to 4x minus 8. So 4x, it's up to you. You can either make the y coefficient positive or the x coefficient positive. I'm going with the x here, so it's going to be 4y minus 6y minus 29 equals 0. Equally valid would be 6y minus 4x plus 29 equals 0. So that's it. That is the equation of our normal. You've got to be careful in these questions. I used a sketch to kind of just explain it, but basically, you know, at some point you need to find the value of y that goes with x. Then you've got a point, differentiate, get the instantaneous gradient, substitute in x, get the gradient of the curve at that point, which would be the same as the gradient of the tangent. Take the negative reciprocal, which gives the gradient to the normal. Quite a few steps, but at that point you've got the gradient and you've got the pair of coordinates. Put it into this and it will, well, a bit of rearranging needed, but it all comes out like that.